Continuing our discussion on ownership principles in Rust, today we will study about slices. So slices are another data type that does not have ownership. We have seen about references in earlier video which did not own the resource, it just borrowed it. So slices are similar to that, and it lets you reference a contiguous sequence of elements in a collection rather than the whole collection. So if you have a string, so references would let you access the complete string, but if you want a slice of it from here to here, contiguous slice, then you can use slices in that case, and you need to specify the first index and one more than the last index. So we will start with the string slices and then expand this concept to general slices. So string slices are also a reference to a part of a string. So rather than a reference to the entire string, it's a reference to a portion of the string. For example, we have a string hello world, and here hello, and then simply writing this would mean a reference to this. But then we have added two more things, start index and end index, and two double periods in between them. So here 0 to 5 means first index is 0 of that slice, and then 5 is one more than last index. So this is 1, 2, 3, 4, and 5 is this space. So we add one extra element here. So 5 is denoting here, but it will mean 1 minus that. So this slice would include these 5 characters. So hello will include HELLO. And world is 6. So this was the 5th index and W was at 6th index, and then 11. So last index is 10. So we have to add one more to it. So 11. So this will include world. So internally, the slice data structure stores the starting position and the length of the slice, which corresponds to end index minus start index. So in this case, 6 to 11 means starting from index 6 and length is 11 minus 6, which is 5. And you can count that it is 5. We will see this in the code also. So internally it works like it has start index and length. So we have HELLO, then a space, then WORLD, and this is at index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this first string S, so it will again contain a pointer, a length and capacity, and length and capacity are both 11 here. And this pointer is pointing to this 0. And if we look this second word, world, which is 6 to 11, so internally it will be represented as holding a pointer and length. So pointer, this is world slice, and the pointer will be pointing to 6, the first index, which is 6 was also the start index. And length will contain 5. So it will start from 6 and go till this. So it will contain world. And when you are writing slices, and let's say your first index is 0. For our case, it was hello was 0 till 5. So if the first index is 0, you can skip this and write it as dot dot 5. So we have skipped 0. Similarly, if say we have s.len, which will be the length, in this case 11. So it will contain 11. So if we have some index 6 to 11, as in the case of this world, so here last index was the length of the string. So this is same as 6 dot dot. So if the last index is same as the length of the string, we can skip the last index. And if the first index is 0, then we can skip the first index. And if we want the complete string, that is first index is 0 and last index is length of a string, we can write it as this dot dot. So we have skipped both the first and the last index. Now that we know about slices, we can understand string literals. So we have talked about string literals, that these are being stored inside the binary. So if this is a string literal, then it's a slice pointing to a specific point in that binary. And its type is this %str. So it's a slice pointing to that binary, and that's why string literals are immutable. So we will see it in the code also. And now that we have understood string literals, we can expand the concept to other slices. For example, we have an array 1, 2, 3, 4, 5, and we want just a reference to a part of this array. Then if we write this, then this is the start index. So it is 0, it is 1. So start index is here, and the length is 2, 3 minus 1. So it will denote 2, 3. And its type is this. So let's write some code and understand that. So let's say S is our original hello world string. And then we create two slices. One is hello, 0 to 5. And this was 6 to 11. And let's print it to confirm that we have understood it correctly. And let's run it. So we see that hello gets hello and world gets world. And now we have talked about dropping this index. So let's drop it and see if there is a change. So there is no change. So if first index is 0, we can skip that. Similarly here, last index was length. So we can drop that as well. And that does not change the output. Now we had said that string literals are slices, immutable slices. So let's create a string literal and assign it hello. So this is a string literal. And let's say this is not a string literal, but that does not make any difference here. So you can see that the type of this is also %str, and this is a slice, and its type is also this. Now we have changed this string literal to a string on the heap, and we run the same thing, and it should not change anything. So we still get the same thing. We get a few warnings because this is not used. Now also let's see the generic slices. So we create an array. And we create a slice out of it. So it's pointing to 1, starting from 1, which is 2 in this case, and then length is 2. So it should include 2 and 3. And we can confirm that by printing slice 0 equal to slice 0. So it should print first element of this slice, which is 2. So let's run it. So we see that it prints 2, first element, and next if we do 1, it should print 3. So we are referring to a small slice of this array, small contiguous slice. Now we cannot access 2 because its length is just 2, 3 minus 1. So if we try to do that, we get an error, which will be out of bound error, index out of bounds, because its length is just 2, so we can access till 1. So in summary, we can say that the concepts of ownership, borrowing, and slices ensure memory safety in Rust programs at the compile time, and the Rust language gives you control over the memory usage in the same way as other system programming languages. But having the owner of data automatically clean up that data when the owner goes out of scope means you don't have to write and debug extra code to get these controls. So that's all for memory principles, ownership principles in Rust. We will continue with further discussion in Rust programming, and we will see how we can group data together using structs. So see you in the next video.